When a chest tube is inserted by a critical care physician, the system is stabilized by suturing. The problem begins with what happens next. Confusion can cause a patient to pull the tube out, leading to trauma and emergency reinsertion. Even during normal activity, the tubing can snag on equipment or doors, causing accidental dislodgement. To solve these issues, we first conducted ethnographic observations in UPMC's surgical trauma ICU to understand how tubes are placed, secured, and managed. From our observations and a bit of ideating, we identified two key design needs: a controlled breakaway zone and a reliable one-way valve. We first started by making low-resolution models, using materials like foam core to mimic the chest wall. These quick models let us test how the breakaway mechanism separated under different pulling forces before moving on to higher resolution prototyping. We also prototyped a simple one-way valve mimicking vein mechanisms to test directional flow and basic function. Using this analysis, we mapped out risks and hazards to prevent failure during use. Once core features were validated, we locked in our final design, capturing the finalized anchor system and breakaway mechanism. Here you can see the fillet tube system in action. Our breakaway connector attaches securely to the proximal section of the chest tube, adding a controlled fail-safe point that prevents traumatic dislodgement. Integrated into the same piece is our one-way valve, which maintains directional airflow and prevents the patient in the event of an accidental pull. Distally, the chest tube is secured with a stat lock style retention mechanism, reducing rotational and axial movement at the skin exit site. Finally, an adhesive dressing is placed over the insertion site to seal the wound. Here you can see the fillet tube breakaway in real scenarios. A strong tug from the patient causes only the distal piece to release, and when the tube snags on a doorway, the breakaway lets go, protecting the patient. After finalizing our design, it is time for testing. Using multiple copies of our prototype, we began by measuring the mass of each device to ensure they aligned with our specifications. Then, using a caliper, we obtained dimensions of each component in the fillet tube connector to verify our design. After this, we conducted pressure and breakaway testing to determine whether the fillet tube functioned under the correct conditions. And finally, we consulted with critical care physicians and nurses to validate our design. Thank you for watching. We're all very excited to see you at the Design Expo.